As I've said before, C# and the .NET framework are object-oriented. Therefore, it's extremely important to know how to create objects because basically that's all that we are going to use within our code. Since Lesson 2, we have worked with objects. Every string, every number, every Boolean, every character that we have used in our demonstrations have been objects. But those have been easy to create because they have literal values. In order to create a string object, all we have to do is string foo equals a string literal, so hello world. And it's that easy. But most data types aren't this easy to do because they don't have a literal value. Now, easy isn't the right word because once you know the pattern of creating an object, you can basically create any object that you want. And of course, there are going to be exceptions, but for the most part, once you learn the pattern, you're pretty much set. And it's a really easy pattern, but you have to know what that pattern is first. So that's what we are going to talk about today is creating objects. And then we're also going to talk about reference types because we've already talked about value types. And now that we are getting into what are called reference types, we need to talk about reference types and how they are handled in memory. So first, let's start off by creating an object, not a string object, but an object of a class. Now, there are multiple terminologies. You can say that I'm going to create an object of a class. That's perfectly fine. You can also say I'm going to create an instance of a class. That is fine as well. An instance is an object. Now, I typically say I'm going to create an object of a data type because everything in the .NET framework is a data type. But not everything in the .NET framework is a class. There's a key distinction because, the integers, the characters, the Booleans, all of those are data types, but they aren't classes. But then we have string, which is a data type, and it's actually a class. So data types are a nice broad way of referring to everything in the .NET framework, and then the word class is just a certain type of data type. Well, let's create an object or an instance of a class called Stringbuilder. And just like any other well-named data type, the Stringbuilder class tells you exactly what it does. It builds strings. And you might think, why do we need a Stringbuilder class when we can just concatenate values together to generate a string? Well, concatenation is inefficient. Now, of course, if we have one or two or three little pieces that we concatenate together, that's fine. But if we have many pieces that we need to turn into a larger string, then concatenation can get a little inefficient. So this is where the string builder comes in, so that we can append different pieces of data and then basically build the string through the string builder class. And it's more efficient than concatenation. So we want to create an object and we want to be able to reference it anytime that we want to. Now, of course, we can create an object and not assign it to a variable. But in doing so, we've basically guaranteed that we can only use that object once because we don't have a way to reference that object after it's created. So we want to create the object and assign it to a variable so that we can reference it anytime that we need to. It's basically just like, what we've done as far as integers and strings and such. We have created those values and assigned them to a variable so that we can reuse it later on in our code. So we create the variable in the same way. We say the data type name, Stringbuilder, and then the name of the variable. But then this is where things get a little bit different. We want to say that we want to create a new Stringbuilder object. So to do that, we use an operator called new, and then we call the constructor of the Stringbuilder class. Now, a constructor is a special method. No, it's not a special method. It's like a special method. We don't have to have an object already to call the constructor, which is why it's special and it's not a method. So the constructor is the same name as the data type. So the constructor name for Stringbuilder is Stringbuilder. And we can see from IntelliSense, it's automatically prompting us to Stringbuilder because it sees that we are creating a Stringbuilder variable and we have said new. So after typing new and then space, it's saying, okay, you want to create a Stringbuilder variable or a Stringbuilder object, and we do. And then we need to call this constructor, and we do so with the parentheses. Now there's actually different ways that we can call the Stringbuilder constructor, and those are called overloads. And we'll talk about overloads later whenever we are actually writing our own classes. So I'm just going to gloss over overloads here. And voila, we have created a Stringbuilder object. And we can use this same pattern to create just about any other type of object. For example, there's a data type called datetime, which represents datetime. It's not a class. It's actually called a struct, and we will talk about structs after we talk about classes. But we can create a datetime object in the same way by using the new operator and then calling the constructor. Now we can actually create datetime objects in different ways, but this at least shows you that we can reuse this pattern over and over again. Well, we can and will use this pattern over and over again to create objects. So there we have it. That's how we create objects in C#. So yay, we're done with that. We can talk about reference types now. If you'll remember from our discussion on value types are stored in memory by their value. So just as a refresher, let's create a variable called x, give it a value of 10. And this does exactly what the code says. We are taking the value of 10 and putting it in the x variable. So x contains 10. Now, it's not quite as clear, but the same type of thing happens whenever we create another integer variable and assign it the value of x. But instead of assigning it x, it takes a copy of the value contained within x and assigns it to y. So x and y contain the same value, 10, but they're different copies of that value. Now, reference types are completely different. And every class is a reference type. Stringbuilder is a class, so therefore it is a reference type. I'm going to change this variable to x just so that I can refer to it easier. So with a reference type, whenever we create an object, that object is stored in memory, and then the reference to that memory is assigned to the variable. So in this case, the x variable does not contain the object. It contains the reference to that object. So it's kind of a link to the point in memory of where that object resides. Now let's create another Stringbuilder variable, y, and let's assign it the value of x. With reference types, we haven't assigned a new value to y. We have taken the reference contained within x and assigned that same reference to y. So x and y point to the same spot in memory where our object resides. So let's see how this actually works. We have two variables that are pointing to the same object. So we can do something like this. Let's do x append, and we are going to build a string using the Stringbuilder class. And let's do hello, comma, space. And then let's use the y variable, append. And append is the method used to append data to the string. And then whenever we call the toString method on the Stringbuilder object, it's going to take all of the pieces that we appended to it and then generate a string from that. But for right now, we're just going to add strings to it. And then we need to display the output. So console, write line, and then x toString. So let's see what this runs. I know what this is going to do. This is going to output hello world. And that is because the x and the y variables are pointing to the same object. So any change that we make to x is going to be seen in y, any change we see or any change we make in y is going to be seen in x. Now, we didn't have to use x here. We could have used y and gotten the same results because x and y are pointing to the same object, and they will continue to do so until we assign a new value to either of those variables. And remember that C# is a statically typed language, and that means once we have a string builder variable, we can only assign a string builder object to that variable. Or can we? We actually have a special value called null, and I'm going to assign null to x. Null is essentially a null object, and it's saying at first, x contains a reference in memory to our string builder object, and then whenever we assign it null, it doesn't contain that reference anymore. It just contains nothing. So x is a null object now, and null can only be used with reference types. It cannot be used with value types. So int foo equals null. We will get a red squiggly here, and it will say that it cannot convert null to an int because int is not a nullable value. Even though value types are objects, they are special types of objects in that they're not containing a reference in memory to the object. They are containing the value itself. So they are special and they cannot be assigned null. However, you can create a nullable value type by just using a question mark. Use the data type int in this case, followed by a question mark, and then you've created a nullable int. So we can assign null to that int now. And that's extremely helpful whenever we're working with databases and working with nullable fields. Okay, so we have assigned null to x. X is null. So let's go ahead and let's try to write that to our console. Let's change this to y so that we first see what x is, we'll change it to x so that we'll see what x contains, then we'll set x to null, then we'll try to write x again to see what it contains, and then we will write y. And now this actually isn't going to work. We are going to get what's called an exception. An exception is an error in our code, and we can see that this is unhandled exception, and we're going to talk about exceptions later on because it's an extremely important topic that needs to be covered, so we will cover them. But this is saying that there is a null reference exception. Every exception has a name of some kind, even if it's just plain exception. In this case, it's saying that we're using null here. We have a null reference, but we're trying to use it as an object. Let's close program and look at our code. And we are doing that here. We have x, which is null now, but we are trying to use it just as if it were a regular string builder object, which it's not. It's null. So we're trying to use a toString method on a null object, and we are getting an exception for that. So whenever we talk about exception handling and things like that, we will need to take that into account because there are going to be circumstances when we are working with data that for some reason is going to be null. And there's really no way that we can plan for that except to handle those exceptions. But we'll talk about exception handling later. So we need to get rid of this toString. And in this case we can, because the writeLine method is going to take whatever value we give it and try to convert it into a string. And a null object is going to basically convert into an empty string. So whenever we run this code again, we are going to see x being written, and then we're going to see x be written again after we've assigned it to null. But in this case, it's going to be a blank line, and then we are going to write y, which is going to be hello world. So let's run it, and we have hello world, and then a blank line, and then hello world again. So we finally got to reference types today, and I'm so glad because it's such an important topic, because you can end up changing an object without really meaning to. And that's something that we will see whenever we work with methods, in the next couple of days, because tomorrow we are going to start writing our own classes. And that's always exciting because that's when we really get to customize our code and really start to write robust applications. But the whole reference type thing is important because we will have methods that will accept data that is an object, a reference type, and we could inadvertently change that object without really meaning to. So it's important to know that difference, and I'm glad that we have finally gotten to that difference. So as I said, tomorrow we will start writing our own class. We will talk about just some of the basic stuff, namespaces and all that. And I hope you're looking forward to that because it is exciting stuff. So have a good rest of the day. I will see you tomorrow.